Welcome to the Stanford Crowd course on Practical Machine Learning with Python. This course was created by the Stanford Crowd Course Initiative. In the last module, you learned the basics of machine learning. This module will go over basic data preparation techniques. The key concepts we will go over are data cleaning, exploratory data analysis and why it's important, how to deal with missing data, and forms of data normalization. Data cleaning is done before any analytical steps are taken and is a very important element of machine learning. Most data analysts in the business world are known to spend about 70 to 80% of their time cleaning and preparing data for modeling before implementing machine learning algorithms. Data generally needs to pass the following criteria: validity, the degree to which the data conformed to defined business rules or constraints. Decleansing is detecting errors and syntactically removing them for better programming. Data integrity refers to maintaining and assuring the accuracy and consistency of data over its entire life cycle. It is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. Uniformity is the degree to which dataset measures are specified using the same units of measure in all systems. In datasets pooled from different locales, for example, weight might be recorded either in pounds or kilos and must be converted to a single measure using an arithmetic transformation. Completeness is the degree to which all required measures are known. John Tukey was a mathematician best known for development of the box plot. In 1977, he wrote a book titled Exploratory Data Analysis, which fundamentally changed the way statisticians looked at data. He articulated the distinction between exploratory data analysis and confirmatory data analysis, believing that much statistical methodology placed too great an emphasis on the confirmatory data analysis. The steps between modeling and analysis are iterative in nature, hence exploratory data analysis is done, models are built, analyzed, and further improvements are made. The intuition behind box plots was presented by Tukey in his book. He was a believer in probabilistic tests and felt that errors typically appear in the form of outliers, and these outliers can be identified easily using visual techniques. As a result of this ideology of exploratory data analysis, today we look for understanding of these techniques when hiring data analysts who are able to employ these methods effectively. We will look at specific exploratory data analysis examples and visualizations in a later module in this course. Data imputation is the process of replacing missing values. Datasets we come across in competitions such as Kaggle are usually clean and ready to use for predictive modeling. However, when we collect our own data for experiments or look at databases of large companies, we can find a lot of problems with missing data. Some of the data imputation approaches are hot deck, cold deck, and model-based imputation. Hot deck imputation is a method where an imputed value is selected from an assumed or estimated distribution for each missing value, in contrast to mean imputation where the mean of the distribution is substituted. One common method of hot deck imputation is nearest neighbor imputation. We first define a metric that measures the distance between sampling units. Then we select imputed values from the corresponding units that are near the unit with the missing value. Cold deck imputation substitutes a missing data element with a constant value from an external source, e.g. a previous realization of the same survey. Cold deck values can be used to jump-start a hot deck imputation. Model-based imputation replaces missing values in the dataset with values predicted by a statistical model. A regression model could be used to fill in the missing values. There are advantages and disadvantages to model-based imputation. Model-based values can be closer to true underlying values. than those obtained via hot-deck. However, it is time-consuming to use and requires high-powered statistical staff with specialized modeling experience. Database normalization is a process of organizing the columns and tables of a relational database to minimize data redundancy. Usually, databases store multiple tables with unique information in each table. Normalization is a very essential part of data cleaning and helps us ensure it is easy to look up tables without any complications. We typically assume that most databases are already in first normal form. This basically ensures atomicity of the database. An example of an atomic transaction is a monetary transfer from bank account A to bank account B. It consists of two operations, withdrawing the money from account A and saving it to account B. Performing these operations in an atomic transaction ensures that the database remains in a consistent state. That is, money is not lost nor created if either of those two operations fail. In first normal form, rows do not have an order. There are no duplicate entries, and there is a primary key or unique identifier upon which rows can be looked up. Sometimes we use a combination of variables to refer to the primary key. This is known as a composite key. The idea of normal form is cumulative, in that second normal form assumes first normal form has already been satisfied, and third normal form assumes second normal form has also been satisfied, and so on. In second normal form, we expect that every attribute that is not part of the primary key is dependent on the primary key. In third normal form, none of the elements of a composite key should serve as unique identifiers. In most settings, third normal form is considered good enough for a database.
And that concludes our video. This course was created as a part of the Stanford Crowd Course Initiative, the world's first massive online open coursework developed entirely by an online community. If you'd like to learn more about us or view more courses, visit crowdcourse.stanford.edu.